Okay, so in the last session, we went through how to make the make a template with our um, based on our proposed typical section, and it's going to be, if we open and map to it, then we can see that this was the basic typical section that we made. And I kind of rushed at the end of last session just so we could put this template together and then apply it to our corridor and to our horizontal and vertical geometry that we created before. So I think what I'm going to do in this lesson is show you. I'm going to show you how to get to this point again, because I rushed. I rushed on how to create a corridor and what is the, and I didn't exactly explain every step that I was doing in the last session. So I'm just gonna delete this this corridor here. So now we just have our horizontal and vertical geometry, and we have our terrain model, and we make sure that it's active right here. And so now, if I wanted to create a corridor for this alignment, I would either click and hover and come to create corridor, or I can come here under corridor modeling, create corridor, and then I'll just follow the prompt. So it says locate corridor baseline, reset for active, which means to right click, and then you can give it a name. So in this case, I'll do 67, and then this design stage is really important. It's really important to know what this is and what's happening when you use different design stages. So we'll just start with 90, and I'll show you the differences between the different design stages. So if we click through, we left click, we give it our name, then it asks, it automatically takes us into the template, into the create template drop command. So as soon as you make a corridor, it automatically takes you here. So then this is the template that I want, so that I'm gonna left click, and then I'll give it the range that I want it in. And in this case, I'll just do some arbitrary just so we can go through how some other cool things that you can see. So I'll give it a start and end station, then I'll left click, and I usually use a drop interval of 20, and so the drop interval, it's kind of, I would just make sure to keep it at 20, and then I can show you how to, we'll actually use the design stage to refine the model and make it more exact, more exactly, where it's going to be more accurate. It's going to be close to what will actually be built in the field. So we'll keep that at 20, and then click through, and it runs. So Now I see my corridor in the plan view, and if I click on this little cursor here, and I go to properties, then I can see these settings here. All right, it gives me the horizontal, it gives me the profile, and it gives me the design stage. And I can change this, and I usually always keep this to true, because it's going to use the active profile that's attached to your horizontal. And so for the design stage, if we change this to 30%, let's see what happens. So you see, so basically when you change the design stage, it either solves more cross sections, or it solves less. So as you increase in design stage, you increase the accuracy in your model. So if we go to 60, actually so I'm gonna move this template drop on this curve, and you can actually see it better with a kind of curve. So if we click on this this purple line, this tells you that it's a template drop, that a template drop is applied to the corridor. And if we select the properties, then you can see that this is the drop interval that we gave it. This is the station ranges, description, and template name. So if we wanted to change our template for this corridor, then we could do that if we wanted to. And if we want to change the end station of this, which I do, then I can either key it in, or I can click and drag this arrow here. And it's gonna, wherever I put it is wherever it's gonna stop. So I'll just key in the end station. So now let's see, actually I'm gonna go a little bit further. So now I'm going to show you what happens when we change our design stage here. So if you see, we have these chords here when we go along the curve, which is it's not really accurate, but the thing is when you use a 30% or a 60% design stage, then it's not going to be as accurate, but it's going to process faster. So that's the trade-off that you have with the design stages. So if we click and hover on the little handles, and we go to 60, then we see that it refines our model quite a bit actually. And then if we click properties and go to 90 again, or 90, then it does it even more, and then if we go to final, then it does it even more. So usually when I'm done with designing and I'm about to cut cross sections, then I'll use the final design stage, just so you can get as close to, or so we can be as accurate as possible. And I don't. So some people may be thinking, well, why don't you change the template drop interval, which you can change here. So let's say if we change it to 10, you can see that it added some cross sections. It added some cross sections to be solved in there, but I usually just keep this at 20. either 20 or 15, something in that range, and then we'll just change the design stage, because this is where how we can control the accuracy of the model. So that's really important to know that. And you also might be actually, let me show you a common mistake that happens when you're creating a corridor. So I'm just gonna delete this, and I'm gonna recreate a corridor. Create corridor. Look at baseline, reset, name. So when you're here, when it automatically takes you to the select template or the template drop command, then and if you right click out of this, right, then you see that we have our corridor with no template on it. But what you need to be aware of is if you, the next step that you would need to do here is to add a template drop to this corridor, right? So you would come, click and hover the corridor. You can see that it's the corridor and it's the name that we gave it, and those are the planar profiles that are going to be controlling the corridor. So if we click on the hammer and we do create template drop, then this is what the next step would be, right? Click our staging limits, template drop, click through. But what I did when I was starting out using the software is I would create the corridor, then I would right click out of the command, and then I would go back and create another corridor. Right? So if I were to do that, then now I have two corridors here. And if you can see, if we go to Project Explorer and we look, if we look, this is our file in our Project Explorer, and we look at the corridors, you see we have two corridors here. So this is the common problem that you can have, and that it's really important that you don't do this, and that you make sure to have one corridor for your alignment and to add template drops to that alignment. So I will click here and go to the hammer, create template drop, or from here, create template drop, or actually I did create template, but it actually needs to be create template drop. So I'll click this, I'll locate the corridor, I'll select the template, and if you want to bring up the template library, then you'll just click down together at the same time, and then it'll give you the option to pick the templates in your library. So then we'll hit OK. This is the template I want to use. I'll click through, give it my ranges. And there we go. And it's, what's happening here? Let's see. Okay, so another important thing that we need to know how to get to is the dynamic cross-section view, and that's if you click on the corridor, then you come to the second icon, corridor views, then you can open the cross-section model, this file. So then you select a view, and then you click inside this view. And I want to change the view of this because it's going to weird. But, so then I'll go to view attributes and change this. And here in the view attributes, you can change the vertical exaggeration if you need to. Or, so you can do it this way, or you can do, if you hold shift and then scroll your mouse, and it will increase or decrease the vertical exaggeration. So let me arrange these views, and then you can see what's all inside this dynamic cross-section view. And this being able
Trey,
to.
I got a quick question.
Okay.
Can you zoom into the cross section? Yeah.
Yes.
So you see the existing ground is not at where you're proposing the widening, right?
Are you
Yeah.
talking about here, or are you talking about
Oh,
here?
yeah, there. So
Okay.
if I mean, if you're widening, you need to make sure that you um, align that existing ground at that location, right?
Right, right. So
So,
the reason this is happening
uh-huh.
is because we're using our. I'll show you. So we're using. We go to another view, and I need to be able to see the. So if we go to the profile view of this, of our geometry, the horizontal geometry, then we're using the best fit profile that we created in the previous session. So this is a reason. This is one of
Uh-huh.
those reasons why. So why don't we make the existing ground um, the active profile of this geometry, and then we'll run it to see how it looks. But I do see your concern, and there is a way to get the existing ground at at that point where you're widening, and then start
Uh-huh.
from that point.
Okay.
There is a way to do that,
Okay.
and it's actually pretty easy. I can show you how to do that in this lesson. So let me let me rerun this. Actually, it looks like, yeah. Let me just reprocess this
Okay.
because I'm
Okay.
not sure if you picked the
Yeah.
profile.
Finish it and then.
But let's see. So yeah, this where is this? This looks like it could be a problem too. Um, but yeah, I can go through in a little bit how to get the exact location of this point here,
Okay.
depending on the distance, or you can have horizontal geometry controlling the of pavement that you're widening, and then
Yeah. Okay.
you can get the existing ground at that location as it moves too. So um, I'm definitely gonna get to that today.
Okay.
But, okay. So here's the cross section view. You can click on the corridor here, open cross section model, and you have this other information too about the quantities and some other reports that it can give you. Um, and I guess let's just talk about the dynamic cross-section view real quick, and then we can go more into the options um, for the corridor. So when we're in our dynamic cross-section view, we we have this line here that shows you where you are. That's pretty cool. You can see where exactly you are. And I like to have the center on current offsets on, because if for some reason I wanted to zoom in here and stay at this location, then it will do that. But if I have this fixed section, then I zoom in, then it's going to automatically fit the corridor. So I guess you can use this when you need to, when you want to. And you should be able to actually see the cut and fill graphics here too, which is another pretty cool feature.
That's pretty cool.
So we can see the quantities here. We can click through. So let me turn these off, and then we can talk about. So when we're in our dynamic cross-section, right-click, and there's these options that we have here. So I usually use the place dimension line to where, for some reason, if your edge of pavement is meandering, you can see the distance on top, and you can see even the slope too. You can do that on both sides if you wanted to, and we can also, if we scroll back a little bit, we can see if we add another temporary dimension line, we can see the slopes of our end conditions as well. And if that changes, then it'll get updated in the dynamic cross-section view, and we'll be able to see the trouble areas that we'll need to either raise or lower the profile, or do some other things to reach our slope criteria. So let's see. So another cool thing to use here is locate station via data point. So if I click here, and I got there by right-clicking in the cross-section view. So make sure to click in this view first, and then we'll right-click, locate station via data point. So then you're going to click either a plan or profile view. So in this case, I'll do the this plan view here, view 1. So I'll left-click in there, and then now, if for some reason I wanted to look at exactly station 907, then I'll key in, and then there you go. I'm looking at station 907. So this is something that I use pretty frequently, and it can be helpful if you're trying to key in on a certain station. And to get rid of these dimensions, if you don't want to see them anymore, you have to remove all temporary dimensions. So I think those are the main functions for the cross-section view, and you can also click this drop down and type in station here. I've noticed that this can sometimes not work, but so if it doesn't, then you can either locate station via data point, or just click here to a station that's close to your station of interest. So now I think let's talk more about what's in these icons here, because these are the really important functions of the corridor. So if I click and hover, then I can see that the hammer is pretty much where I'm going to make all my edits to the corridor if I wanted to. So we can add template drop, and the main ones I use are parametric constraints and point controls, and then we can add super elevations as well. And so this is another really important icon, the corridor objects. So if you click on that, then this is where all the information for the corridor is, right? So here's all our all these topics for this corridor. This is all that's in the corridor. So we can actually make edits here if we wanted to as well. And so let's say I wanted to change this to 40. Then it changes and updates. So another thing to be aware of is sometimes you're making design changes, like you're adding point controls, which I'll show you how to do next, and you're adding parametric constraints, but once you add them, as soon as you add a point control, it's going to process the corridor, right? So what I usually do when I'm adding point controls and parametric constraints is before I add them, I click this button and make sure that it's unlocked. So basically what this means is if this is locked, then any change that I make, it's going to process automatically. But let's say I wanted to change the template drop to here. You see how the corridor hasn't processed yet because this is not on, or this is not locked. So if I click it again and then I reprocess, then there it goes. So this is really important in regards to being efficient with your time, because if you make a lot of edits and this is on, then it's going to process every single time, and it's going to take longer than if you made the changes with the unlock, and then you locked it after you made the changes and then processed it all at once. So I'm going to go back to our template and we'll talk more about point controls and make sure that we're able to point control to the right of way, since that's a usual point control that we want to do for most of our projects and most of our corridors. So let's go back to the template library, and so you see in this template that I have here, there is no point control to the right of way. So, which is basically like you want to have your end conditions either be a certain offset from the right of way or be exactly on the right of way. So let's just start with maybe. Actually, I'm just gonna do it in this US67 template, and then we can make a new template once we've done it to one side. So in this case, I remember in the last session I went really fast in talking about end conditions, so we can talk about it more right now. And so when you click on a point that was made by right-clicking at component and end condition, right? If I make an end condition like this, then it's going to give me certain properties that other points like the pavement doesn't have. And so if I delete this and come back to this cut slope, So I usually keep these two on, and let's say, well, and I usually have the in condition is infinite for the highest slope for either cut and fill. So let me add another in condition here, and then I'll show you how this works. And then we can add the right of way, and we can say stay 2 feet away from the right of way, because we don't want to go any closer than that. So that's what I'll do for this case in this snippet. So I'm going to add a new component. I'll add an in condition. I'll click my. I'll select my feature definition for cut. I'll click on this hinge. If it's white, the points are going to merge, so that's what I want. I'll come here. I'll left click, then right click to finish. Right click and finish, and then I'll click on this point. And we'll just say and then we'll make this in condition infinite. We'll hit apply, and we'll make this slope. We'll just say it's oh my. Okay, so then I'm gonna horizontally constrain this point to this first cut, and then I'll just say 0. Let's see once. Okay, this has to be. That's right. So something's going on here. I'm sure. Let's see. Horizontal. Yeah, we can just keep this like this, and then I'll still be able to show you how this in conditions infinite works. Let's see. So now if I test this, we're going to see that we have in condition priority conflicts. Use the check priorities button to view and fix. So what this is saying is, if we go to check priorities and we come here, this hinge is this little berm here, or this little point. So if we edit, then these are the in condition components that it has. So these values, they can't all be 1. The template doesn't like it when it's all 1. So, but we'll make sure that our shallowest, I believe our shallowest slope should have a lower number than our steeper slope. So let's just go ahead and say this is 2 and this is 3. And this is okay to be 1. So then we'll do okay, and everything's fine. So if we were to draw, then we can see that it, as we're in a cut, and as it's going to keep this this 4-to-1 slope until that ends, and then it's going to go to the steeper 3-to-1 slope after that. So this is the in condition. This is what it means to be when the in condition is infinite. Because once this 4-to-1 ends, then this one continues forever. And the reason this one doesn't extend all the way is because it doesn't have the in conditions infinite box check. So the main time that you would use this is for, or use the in condition as infinite command is when you for your steepest slope. So now let's add a point for the right of way, and then I'll show you how to point control to that right of way, so we can have more realistic grading for this project. Right of way, if we want that. So that I'll put my right of way somewhere, doesn't matter where it is, because we're going to point control to the geometry that we already created for the right of way. So if we, so now that we have our point for our right of way, we can constrain these in condition points to, we can constrain it horizontally to the right of way. So if I click on this first cut, and then I change the point to right of way, and I make it, I want to stay with it. Yeah, for some reason this is not working. So we'll just say, let's just keep it at 6, and let's see if this will do it. So I'm going to move this over. So let me go, let me change this and change it back. Let's see. So we'll just say that it's at 6. Actually, it's moving. Yeah, we'll just change. Say it's at 6, because for some reason this is not. It's not letting me update this value. Let's see if I get positive. All right, that's weird. So let's see. I'm not sure what's going on. Let me. So another thing to know about is if you come here and you want to go back to the last edit, then you can click this last edit. So I'm going to go back twice, and then let's see if this. Okay, so I'll just continue. So I'm just gonna keep this how it is, and then we're gonna. But if you see, these are all, these points are all constrained to the right of way. So you would just make. I guess what I usually do is I make one of these a certain distance from the right of way, and then the other points I make it 0, so they'll tie in at the same point. And then what you can do is you can add a label here, which is for parametric constraints, and we can just say this is the buffer that we want for our right of way. So if for some reason we want to change the buffer from our in conditions to the right of way, then we can later. But that's how I would do it if it was working correctly. So now I'm going to create a new template, and I'm going to combine. I'm going to combine this template that we just edited into this template here, and I'm going to right click and I'll mirror and make sure this is there in the center. And I'm going to actually try one more time to see if I can get it working. So yeah, okay. So Then we'll just, actually, let's make this, let's say it's going to be, and we'll come back to this one. Let's say, so now when we point control to our right of way, then these end conditions are going to they're going to follow the right of way. So if I do close and save, then one thing that you need to be aware of too is, since we made a new template here, we'll need to actually change the template, because ours, the one that we did the first session, was new template 1, and this session is new template 2. So let's change that. So if I click here, I hit OK, and it's not going to process because we have our unlock. But let's make all the edits, and then we'll process it at the end. So the next thing I'm going to do is bring in the right-of-way file, which is here. So now we have a right-of-way, and it looks like, so we can see that the right-of-way is extending out here. But now what we're going to do is we're going to point control to this left and right side right-of-way. So we're going to click on the corridor and go to the hammer, and then we'll do create point control. Then this dialog will come up. We'll say this is going to be left right-of-way. We're going to say the point that we want to be controlled is going to be our left right-of-way. And the mode that we want is both, because we want that point to be controlled by we want it to be controlled horizontally and vertically by this alignment that we made. So then we're going to select the feature definition that this right-of-way is on, which is what I use is geometry right-of-way on most projects. And then we'll give it a range. So in this case, when we're looking to the left of the center line, then we'll use negative. So in this case, and it should be able to pick it up when we process the corridor. So I click through here. And I'm going to process the corridor now. I'm going to bring up the cross-section view so we can see what happens when I bring in my right-of-way. It shows in the cross-section, so this is pretty nice. And let's uncheck the lock, and let's make sure, even though it looked like a process, let's make sure process it again. But if you see, there seems to be no point control to the right-of-way in this area. Let's go. So what happens when you're using the point control by feature definition, the step that you cannot forget to do is to add the add the element that you're searching for as a corridor reference. So you can either come here to this fifth icon, add corridor reference, or you come over here. So then I'm going to locate this left right of way that we want to be controlled and not a template. And then when it loads, so when it loads, then I'm going to reset, and then it's going to process. So if you see, now that our right-of-way is point controlled, our in conditions continue up to 6 feet, or they're not going to go past 6 feet. So if we click through, then we can see that when we do point control, then it's going to have a pink box. And click through and see that it's point controlled throughout. So if the create template is working, then we can change that value to 2 and stay within 2 feet within the right of way. So now I think it'd be a good time to show you how I would find the existing ground at any location along a corridor. So I'm just going to copy this template here. Let's say I'll rename it to and so here we have our template, and I'll just do this. Or not. So what I'm going to do so this is really important, and you can do a lot of cool stuff if you know how to do this. So to find the existing ground at any location for a corridor, all you need to do is have an in condition, and we'll say call it and find existing. So now what we're going to do is we'll have it, but the key to this in condition, finding the existing ground, is that it's vertical line. So it's going to start here somewhere, and then it's going to come down. And we'll give it, I like to use draft DNC for the in conditions. This the finding existing grounds. So now what we can do is we can have this find existing. Actually, let me just say, let's just say control. So what you would do is you would have some kind of horizontal geometry, and you would constrain this point to that geometry. So when it moves, it's going to find the existing ground. But the one thing that you need to be aware of is we need to have the in condition is infinite on this one. Because if we try to test the in conditions and we draw, then it stops. It stops right where the element ends because it doesn't have in conditions. But if we do put it, conditions infinite, test, then it goes forever, and it's gonna find the existing ground, and when we point control this horizontally, then it's gonna find that existing ground along your horizontal alignment that you or along some kind of edge of pavement if you're only widening on the outside, and this is the begin of your work, and you're not doing anything here, then you would have this be that edge of pavement where you're starting to work, and then you find the existing ground there, then you go whatever slope from that point. So then all you would need to do is you could just constrain this point. So we'll say delete both constraints, then we can move it. And in this case, the slope is the slopes are moving together because everything's based on the slope between the center line and EOP. So I guess we can just move this one down. It's fine because it's going to change. So maybe we can just do, let's see, some kind of percentage. Yeah, we'll just keep it up for percentage so it doesn't miss. So it doesn't move like that. So it should be good enough. Okay, so this one to this. So now we move this point to this find existing, and then we'll merge these points. So merge, and when you merge these points, then you have to delete one. So we'll delete this edge of pavement one, and now we're going to see that when we test our end condition, then it's going to follow the existing ground, and this horizontally can be controlled wherever you need to be. So I think this is pretty useful, and if you know how to use end conditions, then you can pretty much do use your imagination and do whatever and solve lots of problems with it.
So, Trey, is that how you're gonna do for US 67 widening? I'm not sure if you're gonna do an overlay on that project, but is that the approach that you're gonna take for that project?
Um, I'm not sure. I mean, if that's what I think it would
Because
be,
go ahead.
I think it would be fine to do that as long as we have the super elevations for the curves, right? Because it's not always going to be crowned.
Yeah.
We're going to have to add super elevation to the curved sections. But I think this will definitely work for that.
Okay. Just was wondering.
Yeah. What do you think about this?
Because if you're only widening, I mean, how do you tie into the existing, and if you were creating a template that has a control point at the proposed vertical alignment, I mean, you're gonna have that variations, right? Like you were showing in the cross section. So I just was wondering how would you how would you proceed with it for US 67?
Yeah. Well, I think I mean, I can apply this. I can apply this template, and we can see how it works.
Mm-hmm.
So let's do that here. I'll just apply it. So I mean, it's going to. This is going to stay at the at the existing ground along this alignment. So I don't know if that's the approach that y'all want to do, because this is what's going to happen. We can
It's gonna
control.
find the, yeah.
Yeah, so it ties in with the existing for sure. I
Mm-hmm.
think it's just a matter of, um, I think really the only tricky sections here is where it's super elevated, it's going to
Super,
flip
yeah.
the other way. But as long as we have some kind of super elevation information, then we can apply that to the corridor, and then it'll be fine that way.
So for typical widening job is this is the approach that they usually take, right? Applying those end condition and finding the existing elevation at that particular
Right,
cross section. Okay,
right, right.
that
Mm-hmm.
makes sense. Okay. Well, thank you on that for
Yeah,
sure.
no problem. So that, I mean, hopefully that cleared up some things.
Yeah, it did.
Okay.
There are some others, but I think that this is where I was looking for how to
Mm-hmm.
create that end condition. And thank you.
Right. Yeah, no problem. And then if you have any other situations that you want to look at, then we can for sure.
Okay. Once you're done with it, we do have some others that we can talk about it, but I think I don't want to break the rhythm. So
Mm-hmm.
let's continue. Okay.
Okay, that sounds good.
Uh,
Well, I think it seems like we're uh, we're reaching our limit here, so maybe I think this is a good place to stop
sure.
and ask for questions to see if anyone has anything. If not, then I'll send out the video, and then y'all can email me or call me any questions that you'll have.
Thank you, Trey. I don't know if anybody has any questions. It looks like none. So
Okay.
again, thank you so much, Trey. Thank
Yeah,
you.
yeah, no problem, no problem.
Have a good day. Thanks.
All right, you too. See you.